The topic which we are going to see today is a Nd-YAG laser. Nd-YAG, it is neodymium, yttrium, aluminium, garnet laser. And these are all the characteristics of laser. This we can come and discuss it later after seeing about it. That is, Nd-YAG is a doped insulator laser. That is, yttrium, aluminium, garnet rod is doped with the neodymium material. So it acts as a neodymium, yttrium, aluminium, garnet laser. That is the active medium and active center. And the pumping method which we use is an optical pumping. And the pumping source is a xenon flash lamp. And optical resonator is that ends of the rod is coated with the two mirrors. One it is partially and another one it is totally reflecting. And the output which we get from this laser is a 20 kilowatt, and nature of output is a pulsed output. The wavelength emitted by the Nd-YAG laser is 1.064 micrometer. Introduction. That is, it is a Nd-YAG laser is doped insulator laser. It is a 4-level energy system. That is, it will be having an energy 4-level of energy system in which active medium is in the form of crystal, and then crystal is doped with the it is a doped crystal during growth. That is, then growing a crystal itself, it is doped with the neodymium ions. Then the energy levels. Here we produce a high power intensity of a laser. The laser produced here is of a high power intensity. And then now we can see what is the principle of this Nd-YAG laser. Here the active medium is a yttrium aluminum garnet rod, which is doped with the Nd3 plus ion, and this neodymium ion has a many energy levels, that is E1, E2, E3 energy levels. These are the energy levels of neodymium 3 plus ions. Due to doping, due to pumping, all this energy which is in a ground state, where due to pumping it goes to an excited state of E4, and during the transition from E4 state to the ground state, it produces a laser light, and the wavelength of the laser emitted is a 1.064 micrometer. Now we can see how to construct this Nd-YAG laser. The active medium is made up of a rod which has yttrium. This is the rod. This rod is made up of yttrium aluminum garnet rod, which is doped with the rare earth metal neodymium 3 plus ion. This neodymium 3 plus ion occupies the yttrium ion. That is, and then we are keeping this rod inside a elliptical cavity, that is a reflecting elliptical cavity, and then we are keeping a mirror. We are also keeping a xenon flash lamp inside a elliptical cavity. The purpose of the elliptical cavity is to make the 100% of light to fall on this laser rod, and then this rod elliptical this xenon flash lamp is connected to a power supply through a resistor and capacitor. That is, the discharge of a capacitor is initiated using a high voltage source. And then that is optical resonator. We are placing an optical resonator. These are the optical resonator. One side of the optical resonator is coated with the 100% reflecting mirror, and the other side it is coated with the 50% reflecting mirror. It is partially reflected. The purpose of this thing is, we know that the photon which is produced by using stimulated emission will travel only back and forth. It will not move up and down. So only we are placing the resonator on the two ends of the rod, not on the top and bottom. So one side if it is reflecting, the rod reflecting, another side it is partially reflecting, means the photon produced will be traveling back and forth between this optical resonator inside a rod till a efficient amount of laser light is produced. After an efficient amount of laser light is produced, the photon will be emitted by a partially reflecting mirror. Now we can see what is the working of Nd-YAG laser. Xenon flash lamp, we are switching on a xenon flash lamp and a light is allowed to fall on a rod. What happens is the Nd3 plus ion gets the energy, which is in a ground state, gets the energy and it moves to a 2 energy level. One it is the 2 N2 and another one it is the N3 energy level. And hence the atoms are raised to a higher energy level, E3 plus. And then E3 plus is not a metastable state, and it is from E3 state due to non-radiative decay, that is spontaneous emission, the electron will move to a E4 state. E4 state is a metastable state. In the metastable state, the atom will take a lifetime of 10 to the power of minus 8 seconds. That, and then here the electron will, here the population inversion is produced, and that population inversion, that is number of atoms in a E4 state is more than a number of atoms in a E1 state. So stimulated emission takes place. Due to the stimulated emission, the atoms in a E4 state, when it move to an E1 state, a light will be, photon will be produced by a stimulated emission. This photon will be moving back and forth between a 100% and 50% reflecting mirror. After the 100% reflecting mirror, the laser light will be emitted from a what? It will be emitted from the partially reflecting mirror as a laser light with a wavelength of 1.064 micrometer. This is the animation video of an Nd-YAG laser. See here. Now the flash lamp is switched on. When the flash lamp is switched on, what happens? That is, when a flash lamp is on, the electrons goes and falls on a, it reacts with the what? Electrons in a light, photons reacts with the electrons in a laser rod. Due to that, this electrons, it's an energy, and the photons will be produced, that is stimulated emission will be produced. Stimulated emission, the photons produced due to stimulation emission will be moving back and forth till a sufficient amount of energy is produced. After that, the laser light will be emitted through a partially reflecting mirror. And the purpose of the here, a cooling arrangement is made either by blowing an air or circulating water over a crystal to reduce the heat. And these are all the applications of Nd-YAG laser. We are using an Nd-YAG laser in transmitting signals to longer distance, and also it is used in a long haul communication. And it is also used in an endoscopic application and remote sensing application.